Okay. 2.3 is linear equations. So the definition of linear is the following. This is definition 2.3.1, linear equation. So a first order differential equation of the form a1 of x times dy dx plus a naught of x times y is equal to g of x. That's an ugly looking g there. So this type is said to be linear in the variable y. Okay. Now, if you divide the a1 out and solve for dy dx, you'll get a naught of x over a1, right, times y equal to g of x over your a sub 1 of x. So what they do in the book, they say let a naught of x over a1 of x equal to a p, capital P of x. And let g of x over a1 of x equal f of x. So then that gives us dy dx plus some p function times y equal to f of x. This is standard form. Okay. So we're going to use this new technique to solve the differential because these will not be separable. So there's no way you can use separable. Although the technique I'm going to show you could work for a separable or a non-separable, as long as it can be written in this form and it's linear, then you're good. Okay. Okay, so what I recommend to you, what I used to do way back in the day, is to use this formula here. So use y equal to e to the negative p of x dx times the integral e to the integral p of x dx times f of x dx plus c e to the negative p of x dx. So the solution y will, in general, if you solve this in general terms, will always be this. Now, if you read the book and go through the derivation, you'll see that they'll use the same technique every single time to derive y, which I think is tedious, and it's going to be the same thing over and over again. So I'm okay with you using this to solve for the actual function. I think it's faster and it's not a big deal because there's many techniques. So why not just have this as another one under your tool belt? Okay. Now, let's see here. Let's see, there's another definition before we start. That's fine. I was looking for a definition of P, but it's not on here. That's not a big deal. Okay, so the P will always be the function slash, well, I guess we should just start calling it a function. Whatever is on the Y, even if it's a constant, it's technically a function. It'd be a constant function, right? So anything on the P, assuming it's in standard form, we'll go here, 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 and there. F will go here, assuming again, it's all in standard form. So it needs to be first in standard form before you begin. Okay. And if F happens to be 0, then that means this chunk will be gone, right? You see that? You'll be just left with this piece, which is kind of nice when that happens. So let's do one like that first. Okay. So example 1, put a star on this. This is the main thing you need for this section. Now the book uses a different technique. They don't use this formula, but I think we should. This integral p of x is also called the integral factor. So that was the word I was looking for. I just remembered. Minus 3y equals to 0. Okay, so in this case, what is my p of x, right?
Negative 3y.
Yeah, it's going to be the negative, well, just the negative 3, right? The y would be here, so we'll leave that part alone. So just this piece. So right there. So p of x is going to be negative 3. Okay. So what is my f of x? Right, it's on the right side, and we don't have one, right? So the solution to the differential, the y function, or y of x, is equal to e to the negative p, which is negative, right, dx, times the integral e to the negative 3 integral dx times 0, which is great. That's going to zero this whole thing out for me, plus c e to the negative 3 dx. So all this will be 0, leaving us with this integral here. Where is it? Yeah. Oops. Now, real quick, notice how the dx is right there, right? That means that this is not inside the integral. So that will be negative the negative 3dx, right? So that's going to be positive. So the solution will be CE to the 3x.
Where's all the gold and the rubies and the dogs and stuff? They must be in another can. Boy, I know the whole yard.
You guys have any questions on Y? Or on number 1 here?
These boys, they ain't got the stamina and endurance to be world-class metal detectors. You know it, Dickens? You know I cut. Oh, about me, hammer. Look here, it's just more than $1 million to me. We came here with gold, let me go check.
Okay. This is pretty straightforward, right? You just use a formula and you get your Y function. Yes, cool. Example 1. So we found the differential equation that will the function that will satisfy the differential. So if you plug this in to here, like we did in 1.1, it will be equal to 0. Okay. All right, let's go to number 2. Okay, dy dx minus 3y equals to 6. So this time it is the same differential, except it's no longer equal to 0, right? So this time the p is the same and the f is the same. So we will use our formula. So y is equal to e to the negative 3 dx times e to the integral of negative 3 dx times the 6, which is the f of x, right? Plus c e to the negative 3 dx. So I already did this piece, so that's good. So this will be y equals to e to the 3x, right, times the integral of 6e negative 3x dx plus, and we did that earlier, that'll be ce negative, or positive, sorry. Okay, so integrate this guy. That will be e3x times, integrate that would be negative 2e negative 3x. Okay. Any questions on how we set up the formula? And we did the integrations. At this point is just some algebra and cleaning up. Okay, so this technique we're going to call the integrating factor. Okay, so that's what we're doing today. So multiply e3x times e negative 3x, these will cancel. This will leave me with a solution of negative 2 plus ce 3x. Any questions on those steps? Is that okay? Okay. So not too bad, right? So the next ones start to get a little more difficult and may require some harder integration techniques or algebra, but the approach is the same. It's not really going to change. But don't forget that you have to put it into standard form before you label P and F and whatnot. Okay. So solve. So notice how it is not in standard form, right? Get that X in the way. So we're going to divide by X everywhere. And then label P and label F. So if I divide by X, I'm going to get dy dx minus 4 over X equal to, and then one of those X's will reduce. Okay. Is that okay with you guys? I skipped some algebra there. But just let me know if you feel if you miss something. So P is what's on the Y, right? F is what's on the X. Oh, sorry, on the right side. So this integral is going to be, well, let's see what happens. Maybe it won't be that bad. So the equation is equal to the function y is equal to e to the negative p of x dx times the integral e to the integral p of x dx times f of x dx plus c e to the negative. Just gonna write it here so I don't forget. Minus plus minus. So I'm going to have negative integral of -4 over x times the integral of e to the integral of -4 over x times this grossness, x to the 5th e to the x. Okay. dx. Now plus c e to the negative -4 x dx. So this would be a simple ln integral, right? That'll be e to the ln x times the integral of e to the negative ln x times this nonsense plus ce to the ln x, right? No. Start simplifying. Let's see here. Now the p of x actually has a hint that I forgot to mention. Notice how x cannot be 0, right? So our domain will be basically x greater than 0. So we don't really need these absolute values here. So these will cancel, leaving you with x times, this is technically 1 over x times x to the 5th times e to the x plus cx. Any questions on the algebra or integration so far? Okay, cool. So this will reduce, right? Giving us x integral x to the 4th ex dx plus cx. Okay. So we're going to do by parts right here. Doesn't matter which one we do here. We could do, yeah, I don't care what we pick for you. Yeah, I don't think it matters. So let u equal x to the fourth, dv equal e to the x dx. The integral would be itself ex. Derivative will be 4x cubed. Formula says that the integral of u dv is equal to u times v minus the integral of v du. So this will equal to x. I'm putting in brackets all the by part stuff. That will be x4 ex minus the integral of v du. So what's going to happen is this is going to repeat a few times because it's a high power. So this is when we should use the tabular method. You guys remember the tabular method? So I'm going to go to the next page in just a moment, and we're going to do this integral. We use a tabular method because it has a fourth power. It's going to keep going forever for a while, at least 2 or 3. So 1 second. One second. Almost found it. Here it is. Okay. I'm assuming you're good on that page. Okay, let's do the tabular right now. So let's pretend that we had a Cal 2 question that said integrate x to the 5th e to the x. That's what we had originally, right? You can double check. 4 actually, it's 4. Again, you don't have to do tabular, but if you don't, you'd have to do my parts 3 times in a row, which is not fun. So this is a shortcut or a different technique. Since this is an iterative method, what you do is you take the u. So the u will always be chosen to be the variable, which is what reduces as you take derivatives. So you start with the original and you start with the original. So all these will be derivatives until you get to 0. These will be integrals until you match up with this guy. So first derivative, second derivative, okay. First, second, third, okay. Fourth would be what's 24 times 3? $48 plus 24.
72.
Thank you. Scared to mess this up at this point. Times 2. And then finally, no more derivatives, right? Okay, so integral, 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 integral. No big deal. So this is the tabular method, and it's going to oscillate between plus, minus, plus because of the built-in negative that's inside by parts. No, man, smeared it. So all you do, you start from up here, you do plus, minus, plus, minus, plus, minus. You one more. There we go. Then you stop. So this integral, this here would be equal to x to the fourth positive times e to the x minus 4x cubed e to the x plus 12x squared e to the x minus 24x cubed e to the x. Okay, plus 72 x squared e to the x minus 144x e to the x plus 144 e to the x. I'm out of space. Do you see how this works? Right, we just pair them off. This times that, this times this. So this avoids all those by parts we would have to have done. Okay, so this is the tabular method. From Cal 2. Sometimes they don't go over it in Cal 2 because it's optional, but you can see that it's useful, right? If you did straight up by parts, you would have to have done this about 4-5 times maybe. Anyway, anything cancel out here? Sadly, no. Okay, so all this nonsense is this integral here, right? So currently I have x outside plus cx. So let's go ahead and multiply that. So I have x, so back to the DE question. It's going to be x times the integral. I'm going to factor the ex because they all have it, right? So factor out ex times, what was on there? Yeah, it was just that. Times x to the 4 minus, oh crap, I already did the integral, right? You see that? That shouldn't be there. So it'd be times e to the x, factoring it all out, times x4 minus 4x cubed plus 12x squared minus 20. Oh man, check this out. You see the mistake? These are derivatives, right? Biscuits. Let's redo that step. Sorry about that. I cannot count, apparently. Sorry about that, guys. I know that's frustrating. Frustrates me too. That happens. All right, let's take derivatives. 4. Take your time, dude. 5x4, 20x3, 60x squared, 120x, 120 and 0. 5, 4, 3, 2, 1. Nothing. Yeah, we're good. I guess we get to practice the tabular more. That's good news. So plus, minus, plus, minus, plus, minus. So again, these are paired just like that. So the integral of x4 ex is equal to ex times x to the 5th minus 5x to the 4th ex plus 20 x cubed ex minus 60 x squared ex plus 120 x minus 120. Okay. So now, again, back to the D. So we had x times ex, that's what we factored out. And we have x5 minus 5x4 plus 20x cubed minus 60x squared plus 120x minus 120. Then out here we had, I think cx, right? Yeah, plus cx. Okay. Double check everything. Any questions on the tabular method? All right, just making a note that we jump to the next page here. I'm double checking my work. Let's see, I did forget the 4. You see that? It's not gonna make a huge difference, but let's go ahead and plug that in. This should be 4 ln x, which would make this a 4th. Make this a 4th. 4. 4. P was negative to begin with. So negative, negative made it positive. Positive. This became should be a negative 4 right there. Dang it. Check this out. Do you see the issue? This is a way easier question than the one I made. This small, forgetting that 4 forces us to do a complicated by parts problem. But here, it actually cancels, giving you just a basic by parts problem. Although that was good practice and interesting, it was not a real question though, was it? You guys have any questions? I don't want to confuse you with that mistake or those 2 mistakes. Do you see what happened here? Do you see why we need a tabular if this didn't cancel? So I'm gonna leave the tabular in the notes just so you can reference it if it comes up. If you get a lot, if you get a problem that's a lot harder, it's gonna be useful. I'll leave it there, but we don't need it right now. U is equal to X. Since it's just a single power, we only need 1 single by parts, which is awesome. Du is gone. V is EX. So this simply became UV, right? Minus the integral of V du. Plus CX to the 4th. And we're pretty much done. See how much easier that was? Yeah, let me make a note here. Formula that I use is U dV equal to U times V minus the integral of V du. Okay. This is the answer. So the next page would just be a bonus. Not necessary. Any questions on this stuff here? Any questions on this made-up problem that I've made over here using tabular? I'll leave that top part. This is fake. All right, so you guys understood tabular and you had no issues with that problem, right? You guys okay with this? Okay, let's go move on then. If you do, let me know. All right. Let's move on. Probably gonna need another page. Just go and start a new page. Okay. General solution. Solve the following. X squared minus 9 times dy dx plus xy equals to 0. So we're going to have to divide that nonsense out, get it into standard form, right? Step 1. Put it into standard form. So divide by x squared minus 9, and we're going to get dy dx plus xy over x squared minus 9 plus, actually that's it, equals to 0. Dy dx plus xy, we can factor that into a difference of squares, correct? So p of x is this weirdness. F of x, thank God, is 0, so that'll make it a little easier. But we're going to have to integrate p of x. Do you remember what type of integration this would be? This is going to be integration by parts, sadly. So step 2, let's just make a little side step here. Usually we don't have to do this. The integral factor. Let's make it a little easier. That way we will know the answer, right? So integral of p of x dx is equal to the integral of x over x plus 3, x minus 3. Okay, so this is so we're going to set up this guy right here using partial fractions. So this will be a over the first term plus b over the second term. We did this, I think, last time, right? Multiply both sides by LCD. That'll give us this. That okay? Well, last time I had you create a system by equating the coefficients. You could use the Heaviside method if you want, but it doesn't matter. I prefer the just making a system. Gather all the x terms together. Gather all the constants together. Create your system. So the coefficient of x is a plus b, right? So equate this to the coefficient of this x. So this coefficient equal to that coefficient. There's a single one in front of that x, right? Single x. These are constants, so just write them down and set it equal to the constant on this side. There is no constant, so it is equal to 0. Solve this. What will that be? Matrix. Oops. To -3. So if you solve that system, let's see, just go ahead and use a graphing calculator or a matrix solver. There it is. New matrix. We got a two rows and 3 columns, right? So 1, 1, 1, -3, 3, 0. So now we tell it to row reduce the matrix A. So there it is. Reduced to 1, 0, 0, 1. A and B are both halves. Interesting. So now we can go back here and say this is equal to the integral of 1/2 over x plus 3 plus the integral of 1/2 over x minus 3. So we're going to continue this on the next page. Do you have any question on the partial fraction step, whether the setup part, the equating the coefficients part, or the matrix part? You guys comfortable with by using integration with and partial fractions? All right, and I'll keep moving at the same pace then. So I have the integral of p of x dx equal to the integral 1 over 2 x plus 3 plus the integral of 1/2 over x minus 3, which will give us 1/2 ln x plus 3 plus 1/2 ln x minus 3. Okay. So all that, these will be, let's go ahead and combine that, I guess. That's equal to 1/2 ln x plus 3 over, actually times. You add logs, you multiply them, right? That will give us this. Which is the same as ln of the square root x squared minus 9. Okay. So now we don't have to worry about this guy anymore. We'll just plug in the solved part. So the formula is equal to e to the negative p of x dx times the integral of e to the integral p of x dx times f of x dx plus c e to the negative p of x dx. So this will simply be e. We already did the integral of p, right? So that'd be negative negative ln square root of x squared minus 9 times the integral of e to the ln square root x squared minus 9 times f, which was 0, wasn't it? Yeah, it was cool. We don't have to worry about this garbage. Plus c negative ln square root x squared minus 9. So all that is gone, which is awesome. So we're left with c e to the negative ln x squared minus 9. Let's write that better. E to the negative ln square root just forgot the c. There we go. That's better. Okay, so that'll cancel out, giving us c over square root x squared minus 9. So y is equal to this weirdness. Any questions on the integral factor or the algebra or the by parts step? Like, I don't care if it's at the beginning or in the middle, just let me know. Does this question make sense? All right. So you will have a couple of initial value problems. I'm probably going to remove the error questions. I'm going to go check that in a little bit, if there is any. But yeah, look at example 5 when you get a chance. It's the same nonsense. It's just they give you a condition to solve for c. So the integral was, well, maybe we can do it. Let's see. P is 1, f is x. So y would be equal to e to the integral p, integral of p, which is just dx, right? Times integral e to the dx times f, which is an x, dx plus c e to the negative integral 1 dx. So that will become e to the negative x times the integral of x ex dx plus c e negative x. Just straight up using the formula, right? This would be a by parts problem, which will be this. So that'll be e to the negative x, and put brackets on this integral. So that'll be x ex minus the integral of v du plus, so that's all in there. So y will equal final answer, right? Once you integrate this, well, no, just show the step. That's fine. X ex minus the integral, which is itself, plus c e negative x. All right, so this is going to cancel all these terms for the most part, giving us just x minus 1 plus c e negative x. So use this initial condition to solve for c. You plug in 0 for all the x's, right? Y of 0 would be negative 1 plus c equals to 4, which implies that c is equal to 5. So just plug in the 5 there and you're done. Anyway, there's no space to do that, but we're out of time anyway. You guys have any questions or concerns on your homework right now? Is there any weird problems that are messing with you? All right, well, you guys are good. I'll see you on Monday then, and I'll be posting some more videos as soon as possible. Okay. And I think Monday we'll talk about exam 1 review and whatnot.
Thank you.
Yeah, thank you too.
Is there nobody else in the class anymore? I know there was a small class to begin with, but
I think I don't know, a couple people headed out early, but it's a really small class. It's like maybe 5 or 4 people in this class. I have to check.
yeah, they don't really do this subject often, probably then.
Yeah, like they split this class into 2 parts. One's fully online, meaning they're mostly on their own, and then there's this one where we are remoting. So
Oh, true. I think mine is fully online, honestly.
yeah,
But
if you're in the 006, yeah, you're fully online. But appreciate you coming to class.
I mean, it helps me learn. But yeah, but you have a good day.
You too, man. I'll see you Monday.